Hey everybody, this is Larry. This is May 7th, the last day of the first week of May Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. And I still need a haircut, but that's besides the point. Just to give you an update while this thing is loading. Okay, today's problem is delete operation for two strings. So given two strings, return minimum number of steps to make them the same. In one step, you can delete one character in each direction. Okay, I mean, so the canonical solution is going to be dynamic programming. You can think about, I mean, if nothing else, and this is, if nothing else, you could think about it as edit distance. But I think there's actually a formal name called like Wiseman or something like that. I am terrible and probably butchering the name. You could Google it, but it's similar to edit distance, except for in edit distance you have add is equal to some cost of 1, I guess. Remove is cost of 1, and change is the cost of 1, right? So you can, to be honest, if you want to use edit distance, and you could use exactly the same code, except for you can, you know, set this to like some infinity. I mean, I would put 1,000,000, but infinity, and then remove, right? And that's basically the same idea. But I generally just do it. I solve enough similar problems to kind of do it as before. And the first thing to do is dynamic programming. So you know, if you're struggling with this one, my recommended research is just reading up on edit distance and playing around with edit distance problem. It is obviously going to be dynamic programming if you haven't heard it before, but yeah, but the idea is that, okay, we start with a function. Let's just call it min d maybe, and then we index 1, index 2, and let's define it precisely, which is that, you know, minimum distance as defined by removing of how do I say this precisely? Substring word suffix word 1 from index 1 onwards, basically the last character, the end of the string starting from index 1, and you know, yeah. And here you can see that the input is O of n square or n times m, depending on you want to separate out the lengths of the thing. And yeah, so let's actually set that up real quick. Length of word 1, I can type very quickly, and then m is equal to length of word 2. And then here, if index 1 is equal to n, we return m minus index 2. If index 2 is equal to m, return n minus index 1. And you may think, or you may ask why I did what this base case mean, and the short answer is that if basically this is saying there's no more characters in word 1, then what do? Well, that means that you delete every character in word 2. That's basically the idea. You could also have maybe represent it like you could have also done something like this, and it's probably fine. Oops. And it's going to be equivalent. We return 0. That means that both strings are the same. And then here you return index 1, index 2 plus 1 or plus 1, because that means that you remove the character at index 2. And similarly, you could have done it here. I mean, obviously they're similar or maybe off by 1, but more or less the same idea. I'm really bad at off by 1, so that's why I always caveat that. But you know, you have to check it at home if you like. Okay. So then now, as we said, okay, so now we have two characters, right? Or two words with the suffix, and then you know you would only delete one character at a time. So we have 3 choices, right? Actually 2 choices. Well, I mean, then some of them are not choices. So let's just go through them, right? Or not choices, but situations, say. So basically, if word 1 of index 1 is equal to word 2 dot index 2. So also we set min answer for now. Let's just set it to infinity. So if they're the same, what does that mean, right? That means that if they're the same, then we can just I wouldn't say remove them, but move the counter at the same time, because that means that they match up, right? So then min is equal to min of the best min, index of index plus 1, oops, index 1 plus 1, index 2 plus 1. And then otherwise, so this is if they're the same, we move the pointers to the right ones. Otherwise, we delete the, we just try all possible things that we can do with these suffix, which is either delete the first character of word 1 or delete the first character of word 2, and see which one is better recursively. So we delete first character of word 1. So this is that. So we skip it, and while index 2 we keep it the same, and now we have this cost of plus 1 because that's the cost of one step, right? So one step, that's why the cost is 1, and then we can also do a similar thing but with the index 2. And then at the end we just return it, and we set it up by, we want to do the whole word, what are the inputs, right? Which is just 0, 0. So that's basically the answer. I know that I didn't do the caching part yet, no worries. If you watch this channel for any length of time, you know that I always go back to it. Well, I hope so anyway. So I probably, the one time that I bring it up is probably when I forget. But yeah, so this looks good so far, but of course this is going to take a long time because this is exponential, because every time you make this call, at the very least it branch out twice and so forth. Let's get a big word real quick. I don't think we have to even go that big, but something like that, and it would probably time out, or should time out, unless there's some funky shenanigans going on. And yeah, and as you can see, it's taking a while. I'll let it run, but the thing with dynamic programming in general, and some of it does take experience to set it up this way, and it's intentionally set up this way, because otherwise you could imagine another definition is something like this, where word 1, word 2, and then you just kind of take the suffix every time, and that's actually fine as well, but it's going to take more space to store, as you'll see later, and sometimes you'll even get out of space and you have to do some math of counting the space. And because the word doesn't change as the function gets called, we're good enough with just keeping a pointer to, or the keeping track of the index of the word. As you can see, time limit exceeded, fake surprise and sadness, but yeah. And then now, so the first thing about memorization is that for every possible input, we have the same exact output, right? Meaning that if you call the same function a billion times, given that, assuming that the words are the same anyway, just to be clear, but if you call it a billion times, it will give you the same answer a billion times. So that's basically the idea behind memorization, is that, okay, in that case, let's trade time for space, or the other way around, space for time, where let's just store down the number, or store down the result, and then return it later in a possible way. So first we look at the possible number of inputs to index 1. Index 1 could go from 0 to n. Index 2 could go from 0 to m. So this is going to be the number of possible inputs is n times m, roughly speaking. Let's put a big O to it. I know that it is n plus 1 and n plus 1 and so forth, but and yeah, and that means that if we can reduce each one of these to a lookup, then, and one lookup, or constant number of lookups, then then that we're good. So let's do what we just said, which is, and I always do it this way, at least on video, so that it's easier to prove the space later, hopefully, as you can see. But yeah, times m plus 1 for and cache is also the same, maybe infinity. Oops, fin. So now we have an m plus 1 times m plus 1 array. And even at this point, before I move forward more, you could see that this is going to be just space bound. So yeah, so it's easy, especially if you're on an interview, to prove the space, because you're just like, hey, we have an m by n dimension matrix, so that's obviously the space. Anyway, so let's kind of keep going. We can do if has cache of index 1, index 2, we return the cache. That's as simple as that. And then at the end of our calculation, we just set the cache to true. Also, oops. I think it was min. And that's pretty much it. You know, all we did was add, you know, a couple of lines, a couple of if statements, and you know, I know that, you know, I think people should definitely be practiced with this, because otherwise it's going to be a little bit painful otherwise. Trying to think whether I may want to stack overflow, but probably not. Or at least I guess we'll see. But yeah, let's give it a submit at this point, and then we'll analyze the complexity. Cool. Yeah, so as we said, the number of possible inputs of n plus m, and because each one of these are going to be O of 1 lookup queries because of the memorization, that means that each one will do at most 3 lookups. So work per input is O of 1. So total work or total complexity is O of n times m, because it's just inputs times work per input. So you get the unit correctly. And that's pretty much it. In terms of space, as we said, you just have a 2-dimensional array or 2-dimensional matrix, and in terms of time, you have this thing, right? So I know that I did it top down because I like teaching using top down. Maybe one day I'll practice, or I'll teach using bottoms up. But I do have a tutorial to kind of walk you through the basics about converting things from top down to bottoms up, and even with a space optimization. For example, for this problem, you can actually reduce this. I know that this is n squared or n times m space, but you can actually reduce this to let's just say O n plus m, but the minimum of either one, if you really want to be specific, to space. And that's part of the space optimization, quote unquote. I don't know if it's a trick, but dynamic programming is about putting things in an order that you already have the result when you need the result. And so as soon as you know that you don't, and space optimization is about knowing that you don't need the results anymore, then you can throw it away and you know, keep space tight that way. But yeah, that's all I have for this problem. That's all I have for May 7th. Let me know what you think. Hit the like button, hit the subscribe button, join me on Discord. And stay good, stay healthy, good mental health. And I'll see you later. Bye-bye.